In this section of these lessons, I'm going to focus more on procedural animation because this is my favorite part of doing animation inside of After Effects with the help of expressions. The way we are going to use these expressions is that we want to make them as customizable as possible to be able to art direct our actions as well. The purpose of this section is to not only speed up the process of animating details of a character or animating some basic stuff, but also to respect the principles of animations. Since there are plenty of expressions inside of After Effects, I'm only going to focus on few of them that are working perfectly for our purpose. I usually combine these few expressions in my animation processes, and I figure that even with these few ones, I can still create some interesting results. I'm going to talk about the foundations of these expressions, what they need to be able to properly function, and then I'm going to build on them and then also combine them together to, again, create some interesting results while respecting the principles of animations. So let's jump into After Effects and see how we can create expressions and then immediately get into the process of using these simple expressions inside our compositions. So I've prepared multiple examples here that I will step by step go through them, and each one of these are made for a purpose, so I'm going to use them as I'm talking about those expressions that I picked for this lesson. So what I have here is a clock that I have separated the hands of the clock itself, so I'm having a seconds, minutes, and hours hands here, and I'm going to animate this in a way that it's constantly moving. I'm going to start with the seconds hand here. So in this case, since I'm interested in animating the rotation of this layer, I'm going to bring up the rotation attribute by hitting R. And we know that whenever we want to keyframe the attributes, we need to click on the stopwatch, set a keyframe, move forward, and then start changing the values, and it's going to animate that attribute for us. So in order to bring up the expression panel for any given attribute, you need to hold down Alt or Option on your keyboard and then click on the stopwatch. And then it will open up the expression editor for that given attribute. The attribute will turn into red, meaning that now it's being controlled by this expression, and we can start typing our expression. I'm going to start with a very simple expression here just to understand how it works. So I'm going to, for example, type a fixed value of 10, and I'm going to hit return or enter on my numpad key. So now you can see the fixed value of 10 is showing up on this rotation. The layer is now rotated by 10 degrees for the entire composition, and it's all done. The point here is that now this expression is driving this attribute, meaning that I no longer have access to this attribute. I can't change it. Even if I change it, the value is still back to a fixed value of 10, which means that, again, this attribute is being only controlled by this expression that I just wrote here. It also means that if I had some keyframes, they're now being overridden by this expression. Just to prove that, I'm going to remove this expression, set a couple keyframes here. So it's now animated. However, if I hold down Alt and click on this to bring up the expression editor and type that fixed value of 10 here, it's no longer reading those keyframes and it's only reading the values from the expression. In future, I'm going to show you how we can respect those keyframes while maintaining the expression. So bear with me, I'm going to cover that in the next parts of this lesson. Let's get rid of these keyframes. Let's start with the simple expression of time. I'm going to tell After Effects to read the current time value and plug it or feed it into this attribute. It means that currently we are at frame 0, the current time is set to 0, and the result is 0. If I move my playhead forward, this current time value is going to change, and that means that the value on the rotation is going to change as well. So this time is giving me a value in seconds, meaning that if I'm in a 24 frames per second composition, if I go to frame 24, which is 1 second, the time is 1 second, the rotation is set to 1 degrees. If I go to frame 48, 2 seconds, and we have 2 degrees of rotation for this layer. It's now rotating over time constantly. I'm getting this nice smooth animation on this hand without setting any keyframes on this layer. If it's a little bit too slow, since this time is a code, I can actually treat it as a value, meaning that I can multiply it by something, for example, a value of 10, which now means I'm asking After Effects to speed up this expression by a factor of 10. I'm going to make it even faster, so now it's going to rotate much faster. And you can see how easily we can speed up or slow down this action without even dealing with keyframes and the graph editor. All right, let's do the same thing for the minutes. I'm going to open up the rotation for the minutes as well. And this time I'm going to write the same expression with some changes. I'm going to multiply it by a factor of 5. So now the minutes hand is also rotating, but it's a little bit slower compared to the seconds hand. I can do the same thing for the hours, and I'm done with the animation for this composition. So that's the time expression, and it's useful for constant increase or decrease of values wherever we want to use them for any given attribute. The next thing that I wouldn't consider to be an expression, but it's very useful when we are dealing with expressions, is when we want to connect two attributes directly together. It will allow us to connect one attribute on one layer to any other attribute in another layer. I have two layers here, and let's say I want the up and down movement of this circle to drive the rotation of this box here. Let's bring up the attributes that we are interested in, the position of the circle, as well as the rotation of the box. Since I'm only interested in the position Y of this layer, I'm going to separate the dimensions of this layer, so I only focus on one of the dimensions of the positions here. I'm going to hold down Alt and click here, and I'm going to read this Y position of this layer and plug it here. I can start typing the name of the attribute that I want to read. However, since I'm lazy and also I can't guess what was the name of it, and in order to avoid any typos, After Effects allows us to use this pick whip and drop it on any given attribute that we can see, and it automatically populates the name of that single attribute of that single layer inside our expression editor. It's a very handy tool, and now you can see, if I want to read this, it says in this composition, this comp, there is a layer called layer 1-circle, which is this, and we are interested in the transform values of that, which is here. And we are only interested in the Y position of that transform attribute. So this is how you can read this expression here. I'm going to grab this circle, move it up and down, and you can see that it's causing the box to start rotating. Also, you can see that if I grab this circle and move it left to right, it's not doing anything just because I'm only reading the Y position of that box to drive the rotation of it. Let's also show that we can treat it as a value, which means that we can do some basic math on it. For example, divide the Y position by a value of 3, and it means that now if I move the circle up, it's going to still rotate the box, but with a slower speed. To have some more interesting examples here, I have this clock again, and this time I'm going to write the same expression on the seconds, this time again using the time expression, and let's make it a little bit fast. So it's going to rotate. And now let's bring up the rotation of the minutes. And in reality, we know that the relationship between these two is 60:1. So whatever rotation I have on the seconds, I can divide it by 60 and I can plug it into the minutes. So in this case, I'm going to read the rotation of the seconds and then divide it by 60. And now I'm getting this result. So the seconds hand is rotating and it's causing the minutes hand to rotate more realistically. So I'm going to speed up the rotation of the seconds. And now you can see that the minutes hand is rotating with it. Similar to that, for the hours, it's going to rotate 60 times slower than the minutes hand. So I'm going to read the minutes hand and divide it by 60. I'm going to temporarily speed up the rotation of the seconds, and hopefully we can see the rotation showing up on the hours hand as well. I have another example here, and I want to make that accurate physical relationship between the rotation of these two cogs. So the way I want it to work is that for every cycle of this larger cog, I want to have 2 cycles for this smaller one. The radius of this small one is half of the radius of this larger one. That's why the relationship between the rotations is supposed to be 2:1. So I'm going to open up the rotation of the second cog, and I'm going to read the rotation of the first cog, and I'm going to multiply it by 2. And now if I start rotating the first one, it seems that it's supposed to be in the other direction, so I'm going to multiply it by -2, and it's changing the direction of the rotation. And now if I rotate the first one, you can see that the connection is properly made for these two. I also have a third one here. The radius of this smaller one is a third of the radius of this large one, so the relationship between the rotations is supposed to be 3:1. So I'm going to open up the rotation of the third one and make the expression to read the rotation of cog 1 and multiply it by -3. And now if I rotate the first cog, you can see that the third one is also rotating properly and things are functional and it looks very realistic. The next expression that I want to talk about is wiggle expression. It's different than a random expression. A random expression generates a random value for every given single frame of our composition, independent from its previous and next values. And it's going to result in some unwanted spikes in our curves. As opposed to the wiggle expression, it's generating a random value. However, these random values are making a very smooth curvature, meaning that every single value is aware of its previous and next values. And that makes this curve to become a very smooth curve, although it's a random curve. That's why I'm emphasizing here that it's making a random curve and not a random value. It's important to understand that still we need to provide it with some information so it knows what range we are interested in and also how fast we want these changes to happen. Whenever we want to write a wiggle expression, we need to provide it with those two information. The first one that defines the range of the values is called amplitude, and the second one is defining how quick the changes are supposed to be, or how fast the wiggle is supposed to change its values. So this one is called frequency, and it defines the frequency of this wiggle expression. So let's have some examples here. I'm having this boat, and let's say I want to write a wiggle expression on its rotation. So let's say the frequency of 2 and a range of 10 degrees for this rotation. It's going to randomly rotate the boat back and forth, and you can see that the range of this random value is something between -10 degrees all the way to +10 degrees. I have these slides here. Wiggle with the frequency of 2 and an amplitude of 1000. It's going to generate a curve for me that is changing its values, for example, 2 times per second. And the range of it is from -1000 all the way to 1000. If I decide to change the amplitude to 500, I'm still getting the same curvature, but this time it's actually compressed in the y-axis. The same exact curve is happening, but this time the range is between -500 to 500. That's the effect of amplitude. On the other hand, if I decide to play with the frequency, this time the frequency is changed to 4, the amplitude is the same. I'm still getting the same random curve, but now it's actually compressed in time, and you can see that the frequency is twice higher than the original wiggle expression that I had. So in this case, if I want this movement to happen faster, I can increase the frequency, same movement but twice faster. Or if I was happy with the speed of it, but rather I want to change the range of these rotations to, for example, 30 degrees, now the boat is going to wiggle slower, but the range of the movement is going to be higher. So while we are here, we want to have the boat to also float up and down. So I'm going to open up the position as well, holding down Shift and P. And then since I want this only to go up and down, I'm going to separate the dimensions of my position. And I only want to write the expression on the Y position with a frequency of 1.5 and a range of, in this case, since we are dealing with Y position, I can go with a range of, for example, 20 pixels to have it to go up and down. Now you can see that the boat is floating up and down as well as it's rotating forward and backward. So I can play with each one of these individually to create an interesting look for my boat. My next favorite expression is the sine function. The sine expression is coming from the sine function that we use in math. That's why when we want to write that inside After Effects, we have to look for that sine function inside the math library. And the nature of the sine function is that it generates a periodic and a smooth back and forth value for any given attribute that we want. The reason why this sine function is also very useful for animation purposes is these smooth peaks that it generates. They actually mimic the eases that we usually are interested in animation. So it's respecting the principles of animation, eases, and we can easily use that for any change of values that we want that is supposed to be periodic and it's supposed to be smooth on the peaks of it. So let's see how we can write it and then how we can modify this expression to our liking. I have this simple clock composition again, and it comes with this pendulum. I've moved the anchor point of this pendulum to be on the base of it, and I want this pendulum to start swinging left and right. The attribute that I want to animate is the rotation, so I'm going to create an expression on it. The sine expression is always uppercase M math, which is loading the math library, the sine expression, and then we need to also provide it with the current time because it's generating a periodic curve over time. So we always need to start with this base expression. Now let's see the result. It is actually rotating the pendulum for me, and it's periodic. However, the nature of the sine function is always generating value that is from -1 to 1. In our case, I want this pendulum to go all the way to, for example, -30 or 30 degrees, or even -40 to 40 degrees and so on. So if I want to change the range of this, I need to multiply this expression by a value of 30 degrees. So now the result is going to be between -30 and 30 because the sine function is from -1 to 1, and now I'm multiplying it by this new value. So now if I check it out, you can see that it's rotating from +30 all the way to -30. This is called the amplitude of this sine function. Also, if you want to change the speed or frequency of our sine function, we need to multiply our time by that frequency. Whenever we multiply the time by something, that is called frequency. So in this case, if I want this movement to run faster, I'm going to multiply the current time by a value, for example, 4, which means that it's going to swing 4 times faster. There's one more thing dealing with the sine function, which is allowing us to shift this whole curvature over time. That is called offset. I can add the offset here. So currently the pendulum starts at rotation equal to 0. I can offset the current time to 0.2, which means that I want this to offset by 0.2 seconds over time. So now the rotation is slightly off center, and now it's going to actually start from that starting point. Just to put all of these together, we have the amplitude, we have frequency inside the parentheses, and offset. Again, I'm starting with this base math sine function here over time that is producing a value between -1 and 1 all the time. That's the nature of the sine function. If I want that range to be changed to -2 to 2, I need to change the amplitude to 2. So the red curve here is representing this new expression here. Then again, if I start with the base math sine function and change the frequency by multiplying time by a frequency value, I'm technically speeding up that curvature. So in this case, the green curve here is again the same sine function, but you can see that I'm having 2 cycles within one original cycle that I used to have. As well as the offset here, so the blue one here is shifted over time, meaning that I'm getting the same amplitude, the same frequency, but the only thing that is changing is the starting point of this curvature. These are the 3 inputs that we can provide with the sine function to modify the effect of it. So I talked about the time expression, wiggle expression, and sine expression, and I also covered how we can connect attributes together. However, still I won't consider these expressions user-friendly. So now let's talk about the issues with these expressions and how we can resolve that. Let's procedurally animate this police car using expressions. I want the car to move forward, so I'm going to animate the tires using the rotations and the time expression, and I'm going to speed it up by a factor of 100. And for the back tire, I can use the same expression, time multiplied by 100. Or since I know that these 2 tires are going to rotate with the same speed all the time, I can connect the back tire to the front tire. So I'm going to only deal with one attribute in case I want to change the speed of it. For the body of the car, I'm going to create 2 wiggle expressions for it. So one for the rotation, wiggle with a frequency of 2 and an amplitude of 5 degrees. All right, maybe a little bit faster. And also I'm going to introduce a wiggle on the position Y. So position Y, separate dimensions, wiggle 4 times with a value of 10. Maybe a little bit faster. For the siren, I wanted to start blinking. So the expression that I'm going to use for this is going to be sine function because I'm interested in periodic change of values. First thing first, I'm going to create the glow effect that I want to animate. So for that, I'm going to duplicate the siren. I'm going to name this glow, and I'm going to create a fake glow effect by using the fast box blur, applying it to the glow layer and then increasing the blurriness, turning off the repeat edge pixels, and it's going to mimic the glow effect for me. The attribute that I'm interested in animating in this case is going to be the opacity. So the expression that I want to write is going to be on the opacity. Math sine of time. This is always my base. And we'll learn that it's going to generate a random value between -1 and 1. I want the values to go from 0 to 100. I'm going to shift the entire curve up above the value of 0 by adding a value 1 to it. This entire curve is going to be above a value of 0. It's going to reach a value of 2 and then coming back to a value of almost 0 and then periodically moving up and down. So it's good. It's no longer giving me negative values. It's from 0 to 2. However, I want it to be from 0 to 100. So I can multiply the whole thing by a value of 50, and now this value is going to go from 0 to 100. It's a little bit slow, so I'm going to speed it up by increasing the frequency. I'm going to temporarily change the background color to something darker, maybe slightly faster. We animated this car all through expressions. No keyframe is made here, and we're happy with the result. The problem here is that we are never done with what we like to get. We might need to change the timing. We might need to change the frequency, the range of movements. We always want to be able to change those values if we want to. In short, I will call it art directing our animation. I want to make sure that whenever I want, I can change these values very easily. The problem currently here is that if I want to change, for example, the speed of the wiggle or the amplitude, amplitude of the wiggle or the speed of the rotation of the cars. I have to one by one go through each one of these layers, find the values that I'm interested in and change them. Currently, I'm dealing with simple expressions, so it's easy to find those values. However, sometimes we're dealing with more advanced expressions. For the body, for example, it's hard to understand which attributes are having the expressions on, so I have to just open up all the values, find those expressions, and again change those values here. It's a little bit a tedious job, especially if I'm dealing with multiple layers. The other major problem with this type of expressions is that they are not animatable, they are not keyable. So if I set the wiggle frequency to 5 in this case for the position, this value is going to be a fixed value for the entire composition. I cannot animate these values, and this police car is always going to have this wiggle for the entire duration of this composition. We know that we want to be able to animate these. With these expressions, we are not able to do those. So in order to solve these issues, we need to create some custom attributes or sliders and then connect those sliders to these values that we want to change. We are bringing them out of these expressions. We are exposing them to the user, and the user can easily see them, and also they can animate them as well. Let's start with the wiggle here. And I know that I want to be able to change the frequency and the amplitude of this wiggle. So I need to have two custom sliders. The sliders in After Effects are of type of effect. So if I want to create a slider on a layer, I will go to the effect, I will find the expressions, and the slider controller is the type of controller that I'm interested in. I can either find these effects from this menu, or since I know the name of the expression that I'm looking for, I can just type in the slider and I can drag it and drop it on this body, or I can double click on it and it will add it to my layer. These are considered effects on this layer. You can see that if I change my selection to any other given layer, those effects are not showing up because effects are actually applied to layers. So in this case, I have two sliders here. I'm going to rename them by right-clicking and going to rename, or I can hit return on the keyboard and rename them. I need to have 4 sliders, and I'm going to name them after each one of those attributes. So the first one is going to be position Y, and it's the amplitude. This one is position Y, and this is going to define the frequency. I'm going to duplicate this one more time, and this is going to be rotation, amplitude, and rotation frequency. So now that we have these sliders available on this layer, as well as they will show up here as effects in the timeline, I can use the direct connection to replace these fixed values with those sliders that I just created. So in this case, I want the position Y frequency to be replaced by one of the sliders. I'm going to remove the value 5, and I'm going to use the pick whip to connect it to position Y frequency. Now this wiggle frequency is being controlled by this attribute here. I'm going to do the same thing for the amplitude as well. So I'm going to remove number 10, and I'm going to use the pick whip and connect it to the amplitude here. Just to show you one other way of connecting these values, I'm going to collapse the effects attribute here, and I'm going to connect them in the effects controls here. This time we are dealing with the rotation. So I'm going to remove number 3, and using the pick whip, I'm going to pick the frequency slider here and also the amplitude. So now the beauty of these sliders is that I can collapse these expressions. I know the attributes are exposed here, and I can change them. So 10 pixel wiggle with a frequency of, for example, 4, and a rotation of 4 degrees and a frequency of 3. The wiggle is now again in effect. The beauty of it is that I can animate these. So for example, if I want the car to not move at all for 30 frames, I'm going to animate the amplitude of these 2 wiggles, set 2 keyframes on it, hit U to bring up the keyframes and attributes, and I'm going to shut them off, 0, then gradually increase the wiggle so it doesn't suddenly start wiggling, and then maintain that wiggle for a while and then shut it off after that. It's beautiful, it's customizable very easily, and it's also animatable. I can do the same thing for the siren. So I'm going to open up the glow. I'm going to create 2 sliders, one for the amplitude and one for frequency. And I'm going to replace this amplitude with that amplitude slider. And I'm going to do the same thing for the frequency. Now, this time I can have the siren to be off. So I'm going to turn off the opacity to 0. There is no blinking, but suddenly it starts blinking, and then it maintains that blinking, and then I will shut off the glow. Like that. This is the beauty of procedural animation. I can always modify that. So in case, for example, I'm not happy with the bumpiness of the road, I can increase or decrease the amplitude of rotation wiggles or position Y wiggles. For example, make the road to be a little bit more bumpy. I can even ease these keyframes, so hitting F9 on them. I can increase the rotation wiggle as well. So now I'm dealing with a more bumpy road in this case. And again, everything is procedural. And to be honest, it's very hard to create such an animation using keyframes to create such random curvatures on the rotations and positions. Now you can see that it's very easily created and also it's very customizable. The next attribute that I want to talk about, which is very, very handy in animation, and it also represents another principle of animation, is the valueAtTime. This sort of expression allows us to read the value of an attribute at a specific time in the timeline. Let's see how it works first, and then we're going to build on that. I have this basketball here. I'm going to animate this. I'm going to separate the dimensions. I always do that because this gives me individual control over Y position and X position. So I'm going to animate this ball to do a bounce. I'm going to take care of the eases here and also make the hit to be a bit more pointy to make a nice bounce here on the ball. And now I'm going to duplicate this. So Control D, I'm going to first shift it to the right and then get rid of the animations on it. We have an animated layer and we want to read the values of this attribute somewhere in the timeline. In order to do that, I can write an expression on the other ball, read the Y position of the first ball. So now these two balls are doing the same action. At frame 5, the value of the first ball is 597. The value of the second ball is 597. However, with the use of valueAtTime, I can say I want to read this value at this time. For example, time 1 second. So 1 second in this composition, the first ball is at this position, 615. The second ball is also at 615. However, if I move my playhead, the second ball is always maintaining that exact value, which is coming from the Y position of the first basketball at 1 second in my timeline, which is 615. So this is picking a fixed value at a given time for me. I want this basketball to also move with the first one. So rather than just picking a fixed value of 1 second in my composition, I know I have access to the current time of my playhead. So now these two balls are moving together. The point here is that we can also introduce some offset or delay here as well. Rather than reading the value at that given time, I can say I want to read it with a delay of 0.1 seconds. So this means that I'm having a delay on the second basketball. You can see that it's doing the same action, but it's having a 0.1 seconds delay. I can increase that delay to something more dramatic. So I'm going to make a more complex scene. I'm going to remove this expression, push the first ball to the left. I'm maintaining the same action on it. I'm going to move the second ball to position X of 500, and I'm going to duplicate it multiple times, shifting each one of them by 300 to the right. Let's get rid of the last one. If I want to create an interesting bounce on these balls, what I can do is I can copy these keyframes and I can paste that on the rest of them on the position Y. So now these balls are going to bounce all together. Now in this case, if I want to offset these animations, what I traditionally will do is I will offset the keyframes in the timeline. So I'm going to offset them by 2 frames, and I'm going to do that individually for each one of these layers. It's an interesting offset between these bounces. However, since I've done it through keyframes, it means that if I want to modify the timing of these bounces, I need to select all of these and retime them. Or if I want to change the delay between them, I need to again go back here and reintroduce a new delay for these, and so on. That's not ideal. I want to be able to modify these delays very easily, especially when I'm dealing with multiple layers. Since now I learned about the valueAtTime concept, let's just deal with this using those expressions. I'm going to get rid of all of these keyframes. And this time I'm going to read the Y position using the expressions. The second ball is going to have the same Y position with the delay, valueAtTime. And let's say we want to have a delay of 0.1 seconds. I'm going to repeat this process for the rest of the layers. So I'm going to copy this last part of the expression. And I'm going to do the same thing for these ones. So ball number 3 is going to read the position of ball number 2 with a delay of 0.1 second and so on. We're getting the same result. However, this time I can actually retime these, and the rest of the balls are going to maintain the same action with the same delay that I introduced here. However, I don't like the way that I set them up, because what if I want to change the delay? I need to go and find each one of these expressions and manually change these delays. For example, to a 0.2 seconds delay. I wouldn't consider this a user-friendly expression. I will create a custom attribute or a slider on the main basketball, and I will call it delay. And I'm going to plug that delay into all of these expressions so I can change all of these values all together using just one slider. I can temporarily lock my effects panel, and it's safe to change my selection, and I'm not losing that effects panel anymore. So I'm going to do the same thing for all of these. And now I'm able to change the delay all at once, the delay of 0.15 seconds. Or I want to have a larger delay, 0.3 seconds. Awesome. So you can see that I'm dealing with only 3 keyframes here. I can modify the timing and I can modify the delay. So while we are here, let's also introduce a very simple expression. I can just create that expression on a given attribute and it will loop that animation for me. So in this case, I've just created one cycle of the bounce for the ball. What if I want to repeat that? So traditionally, I would just copy these keyframes and paste them over and over to get these bounces over and over. However, I can use an expression on this Y position. This is one of the places that the expression will respect our keyframes. So I'm going to alt click on this stopwatch and type in loop out. And the type of loop that I want to get is the cycle, which means that when it reaches the final keyframe here, it will cycle back to the first keyframe. Uppercase and lowercase is important, so it's uppercase O. Now the bounce is looping, and because of all of those value at times, all of the balls are going to be looped. Let's exaggerate the hits. You can see that it's affecting all of the balls. That's the beauty of procedural animation. Let's decrease the delay because now we're dealing with faster actions. Let's also talk about one more thing that helps us to speed up the process of building the expressions. You might have noticed that when I wanted to create these expressions for the remaining layers here, I needed to make the connection one by one individually for every given layer, because this layer is going to read the Y position of this layer, this one is going to read this layer, and so on. So for such cases that I'm creating the exact same expression for multiple layers and the only thing that is changing is the layer name, I usually avoid using the layer names, but rather I will rely on the layer indices. So I'm going to remove all of these expressions one more time. Again, I'm going to do the same thing. I'm going to read the Y position using the valueAtTime. I'm going to read the current time minus the delay that I want to get. Now I'm going to remove the name of the layer to make it more generic. And then I'm going to replace it with the index number of that layer. Index number is referring to this number that you might see on these layers. So currently the index number of this layer is 5, this one is 4, 3, 2, and so on. Since I know my layers are always stacked on top of each other in the correct order, I can rely on these indices. And I can say, rather than reading the values of a layer called basketball PNG2, how about I read the index number of it? And this index is referring to the index number of this exact layer that this expression is sitting on. This is not what I'm looking for. I'm looking for the index of this layer plus 1. So I'm going to say I want to read the values of the layer underneath me. And this expression now is generic enough that I can actually use for all of these layers. And I know that I no longer need to change any names on those expressions anymore. Let's copy this whole expression and paste it on the next one. For this one, it's saying that look at the layer number 5, which is index 4 plus 1. Look at the Y position with a delay that is driven by a slider found on the layer called basketball PNG. I can copy and paste these expressions, or there is a feature in After Effects that lets me to only copy the expressions and paste it on multiple layers. So I'm going to remove this one. I'm going to copy the expression of the Y position, copy expression only, and select the rest of the layers and Control V to paste the expression on all of them. And now you can see all these layers are having the same exact expression. And since the expression is generic enough, for each one of them, it's looking for the next layer underneath it. So I'm getting the same result with the same expression for all of these. It takes a while to create these expressions, but at the end, you can build on that. And for example, I can copy the last layer, duplicate, and it comes with all the expressions on it. It's now looking at this layer after that. I just need to move it to the right, inheriting all of those expressions that are properly functioning for the entire composition. This valueAtTime is perfect for cases that we are dealing with FK chains and we want to create a delay or overlapping action between each one of the joints. In fact, I've created a new composition and I'm having a hierarchy here with multiple joints. I'm having 7 joints here. They are all parented to each other. Each one of these layers are having their anchor points on their base, and that's giving me that nice curvature when I'm rotating all of these layers together. So let's start using that valueAtTime expression in this case to see how it's going to give us a very nice overlapping action, which is another principle of animation. For that, I'm going to animate the rotation of the first joint. So I'm going to start from a positive 30 degrees and I'm going to have one complete swing. So I'm going to have another keyframe at frame 20, and in between I'm going to animate it backward and it's going to swing. Smooth out these keyframes, F9, loop out expression here as well, and I'm going to cycle it. So I'm getting this nice swing on this. I'm going to immediately create the slider and I'm going to name this delay. Very well. So on the second joint, I'm going to read the rotation of the first joint using the valueAtTime. I'm going to read the current time minus the delay. Since I know that I'm going to use this expression for the rest of them, I'm going to make it generic. Copy this expression and I'm going to paste it on the rest of them. So now we are getting that rotation for all of those, with the exception that the delay is still not introduced. So I'm going to go back to the first layer and I'm going to introduce a 0.1 second delay. I can slow down the swing and you can see that it's fully procedural, meaning that I can change the delay to my liking, probably reduce that. Considering the principles of animation, these are the C curves and S curves that we usually want to create manually when we are creating such an overlapping actions in our FK chains. Before wrapping up going over the foundations of these expressions, I want to also talk about one more thing that we might actually deal with when we're writing expressions on a given attribute. So I'm going to go to this new composition and I have a ball here, a simple layer. And let's say I want to animate this ball to travel from left to right and also go up and down using the Sine function. So I'm going to open up the position. I'm going to split the dimensions and the positions. And for the X position, I'm going to write an expression using the time and I'm going to speed it up. For the Y position, I'm going to write the math Sine function over time. And since this is a position value, I'm going to increase the amplitude of it to something larger. So for example, 100. So as soon as I create this new expression on the ball, it jumps up to the top edge of my composition. It is doing the sine periodic movement. I'm going to increase the frequency here as well to get more cycles. However, because of the nature of the sine function, we learned that it's actually generating values between 100 and -100, which is actually outside our composition. We also learned that when we are creating expressions on attributes, most of the expressions are overriding our default values or any given keyframe that we might have had on those attributes. If I try to change these values, you can see that I no longer can do that because of the existence of these expressions. So for these two reasons, I want to talk about one more thing that allows us to gain back the access to these values on the attributes and then combine it with the expressions that we write on them. So in order to get access to these values here directly in our expression, we can actually link to those values here directly as well. My Y position is a combination of the value that I type in here as well as the expression that I type here. So this way, not only I can change these default values on them, but also I can animate them because I know that my expression is also respecting those values. You can see that the ball is doing that sine function and then suddenly I'm dealing with this keyframe which will cause the ball to fall down, and while doing so it's still maintaining that sine function on it. Similar to that, I have the same situation on the position X attribute here. I can go back to my expression and link to the value that I want to read here and then add it to my expression. I can actually reposition the ball and then the time expression is going to be added on top of that. So to make it more practical, I'm going to this time create the wiggle expression on the rotation and position Y of this boat. However, this time I want to have a relationship between the wiggle that I get on the Y position and the rotation to make it more natural. So I'm going to start with the rotation and I'm going to create a wiggle on it. The wiggle expression is in fact one of the exceptions that whenever you type it on a given attribute, it does respect the values on that attribute as well because it's actually generating random curves around that default value. All right, so I want this to go up and down with an overlapping action when the rotation wiggle happens. So on the Y position, I'm going to maintain the current position and then add on top of that whatever rotation I get from the wiggle, and I'm going to give it a delay. And now what I'm going to get is, while it's rotating forward, it's going to come down with a delay, which will cause this movement to go with some overlapping action and make it more natural. Since the rotation range is between -10 and 10, I want the Y position to go a little bit higher than that. So I'm going to multiply it by, for example, a factor of 3. And now let's see the result. It is wiggling up and down, but since I introduced this delay here, it's giving me that nice overlapping action on it. So let's just increase the delay even more and see if we like the result. And I like it.